Today's problem is game with string. Not the kind of string that you would play a game like with your cat. I mean, we're programmers here, so it's a string of characters. Difficulty is medium. Given a string S consisting of lowercase, let's say letters, and an integer, k, your task is to find the minimum possible value of the string after removing exactly k characters. The value of the string is defined as the sum of the squares of the frequencies of each distinct character present in the string. Okay, that probably needs an explanation. Let's see. All right, so let's take this one. We have string is A, B, B, C, C, C. So the frequencies initially are 1 for A, 2 for B, 3 for C. We could remove 2 C's, and then we have frequencies of 1, 2, 1. Or we could remove 1B, 1C, either way. 1, 1, 2. Square each of the frequencies, add them up, and the output is 6. This one, A, B, there are too many A's here. So we can remove 2, we'll remove 2 A's, and do the sum of the squares of the frequencies. Expected complexity, linear, O of n. Amazon may ask you this question. Topic tags, strings, heap, data structures. Yeah, that makes sense. So we're doing this in Java. Java has a built-in data structure called a priority queue, which works like a heap. So let's take a look here. Whoops, does this go over any further? I thought it might, but I guess it doesn't. All right. Well, in that case, let me just move this over here. Okay, let's see. Here's our input. We've got a string. We've got an integer. We're going to create a hash map. This is actually like the last problem that we looked at, which was removing one character from a string and trying to equalize the frequencies. But we're doing the same thing. We want to get the frequency of each character. So we've got a map here. The keys are characters and the values are integers. In this case, they're frequencies. Frequency map. So we'll iterate through the string, the input string, and either add or increment a value. All right, now comes the heap. All right, what we want here is what's called a max heap. Normally, if you just the default behavior of a priority queue is to queue the entries in an ascending order. All right. Now, if you're going to do something like we're doing here, we want a max queue. We want the maximum value first. Also, our entries in the priority queue are a little bit unusual. We're not just like queuing integers, for example. We're queuing map entries. We're going to queue the entries from the frequency map. So we'll declare it like this: priority queue. The type, we've got to say the type, and the type is a map entry of character and integer. We'll call it max PQ. New priority queue. All right, and then we have a comparator function. We have to provide a custom comparator function. Entry 1, entry 2, you can call those anything, but what we're doing is we'll say entry 2 get value because we want to queue these based on the value. We want the entries with the highest frequency first. So when we say entry 2 compared to entry 1, essentially we're just reversing the default order. All right? Max PQ, add all. So we're going to add everything in the frequency map to the priority queue. And then a loop. We'll go through a loop k times because we get to remove k characters. So each time through the loop, we will pull the queue. We will get the character with the maximum frequency. We'll decrement that frequency, and we'll put it back in the queue. All right. Now we've got to just do the computation for the result. We'll set up an iterator here. This is going off the page. Let me just do this. All right, so we'll set up an iterator. Again, this is an iterator for map entries, maps of characters and integers, an iterator on the priority queue. All right, we're going to go through the entire priority queue and get the next entry and square the value and add it to result. Return the result. Okay. Move this back, submit it, see what happens. All right. So let's see. What were the keys there? HashMap. The HashMap thing was exactly like the last one that we did. Trying to equalize the frequencies. Okay. So the HashMap, and then the priority queue, which if you go to an interview, they may not tell you, hey, use a heap. If we do it here, we can look at topic tags that use a heap. But yeah, that's a key as well. We want to remove characters with the highest frequency because that is going to minimize our value. Okay. Priority queues and heaps. That's it. Like the video, subscribe. You'll get problem of the day. Just it'll show up right in your inbox every time I post one, which should be on weekdays. And we'll see you next time.